Hello everyone. Today our topic name is disk structure. Definition of a disk structure. The actual physical detail of a modern hard disk may be quite complicated. Simply there are one or more surfaces. Each one contains several tracks, which divided into sectors. Here we can see two diagrams. Easily understand the disk structure. After disk scheduling is done by operating system to schedule input-output request arriving from the disk. Disk scheduling is also known as input-output scheduling. Importance of disk scheduling in operating system. In this, multiple input-output requests may be arrived by different processes and only one input-output request can be served at a time by the disk controller. Thus, other input output need to wait in the waiting queue and need to be scheduled. Another is two or more requests may be far from each other, so this can result in greater disk arm movement. Hard drives are one of the slowest parts of the computer system and thus need to access in a efficient manner. After we can see some disk scheduling algorithms. FCFS, first come first serve. SSTF, shortest seek time first. SCAN, elevator algorithm, or CSCAN, circular scan. Look, CLOOK, RSS, LIFO, last in last out. And step scan, FSCAN. After we go into this scheduling algorithms, you can know some key terms. Firstly, may seek time is the time taken to locate the disk arm to a specified track where the data is to be read or write. So the disk scheduling algorithm that gives a minimum average seek time is a better. Next one is rational latency. Additional latency is the time taken by reserved sector of the disk to rotate into a position so that it can access the read heads. So the disk scheduling algorithm that gives minimum rotational latency is better. Next one is transfer time. Transfer time is the time to transfer the data. It depends on the rotating speed of the disk and the number of bytes to be transferred. Disk access time. Disk access time is equals to seek time plus rotational latency plus transfer time. After total seek time is equals to total head movement plus into seek time. You can see some draw diagram of a key terms. After disk response time. Response time is the average time spent by a request waiting to perform its input-output operation. The average response time is the response time of all requests. Variance response time is the measure of how individual requests are serviced with respect to average response time. So the disk scheduling algorithm that gives minimum variance response time to is better. We can see detail about disk scheduling algorithms. First one is first come first serve. It is the simplest of all disk scheduling algorithms. In FCFS, the requests are addressed in order they arrive in a disk queue. I can see an example. After example, some advantages of FCFS. Every request gets a fair chance. After no indefined postponement. Disadvantages of a FCFS. Does not try to optimize seek time. May not provide the best possible service. Another one is shortest seek time first. These requests having the shortest seek time are executed first. So the seek time of a very request is calculated in advance in the queue and then are scheduled according to their calculated seek time. As a result, the request near the disk arm will get executed first. Shortest seek time first is certainly an improvement over FCFS as it decreases the average response time and increase the throughput of the system. We can see an example. After some advantages is the average response time decreases and another one is throughput increases. And the disadvantages of shortest seek time first is overhead to calculate seek time in advance. Another can cause starvation for a request if it has higher seek time as compared to incoming requests. The high variance of a response time has SSTF varies only some requests. Another algorithm is scan algorithm. In the scan algorithm, the disk moves in a particular direction and serves the request coming in its path, and after reaching the end of the disk, it reserves its direction and again serves the request arriving in its path. So this algorithm works as an elevator and is hence also known as elevator algorithm. As a result, the request at the mid-range or serviced more than arriving behind the disk arm will have to wait. You can see example. After advantages, high throughput, low variance, average response time, disadvantages of a scan algorithm. Long waiting time for a request for locations just visited by a disk arm. Another algorithm is C-scan. The disk arm again scans the path that has been scanned after reversing its direction, so it may be possible that too many requests are waiting at the other end. There may be zero or few requests pending at the scanned area. Can see an example. Advantages: provides more uniform wait time compared to scan. Disadvantages: it causes more seek movements as compared to the scan algorithm, and it causes the head to move till the end of the disk even if there are no requests to be serviced. Another algorithm is look. Look is a similar to the scan disk scheduling algorithm, expect more the difference than the disk arm. In spite of going to the end of the disk, goes only to the last request to be serviced in front of the head and then reverses its direction from there only. Thus, it prevents the extra delay which occurred due to the unnecessary traversal to the end of the disk. You can see example. Another is CLOOK. A look is similar to the scan algorithm. In a similar way, CLOOK is similar to the C-scan disk scheduling algorithm. In CLOOK, the disk arm, in spite of going to the end, goes only to the last request to be serviced in front of the head and then from there goes to other end's last request. And see example. And advantages of CLOOK: it does not cause the head to move till the end of the disk where there are no requests to be serviced. It reduces the waiting time for cylinders just visiting by the head. Disadvantages: it may lead to starvation of a request that are located far away from the current position of the disk head. Another is RSS. It stands for random scheduling, and just like its name, it's natural. It is used in situations where scheduling involves random attributes such as random processing time, random due dates, random waits, and stochastic mission breakdowns these algorithms perfectly, which is why it is usually used for analysis and simplification. Advantages: randomized algorithms are known for their simplicity. Any deterministic algorithm can easily be converted to a randomized algorithm. Randomized algorithms are very efficient. They utilizes the execution time and space compared to any deterministic algorithms. Disadvantages: the algorithm requires solving a hard combinational problem each time slot, for example, maximum weight independent set of wireless network, which is NP-hard in general. Therefore, it is far from being particularly useful. This scheduling method is non-primitive, that is, process will run until it finishing. Because of this non-primitive scheduling, short processes which are the back of the queue have to wait for long process at front to finish. Throughput is not sufficient. Another is LIFO algorithm. In LIFO, last in first out algorithm, the newest jobs are surfaced before the executing ones. In orders of requesting that get serviced, the job that is newest or lastest enter is serviced first, and then rest in the same order. Advantages: maximizes locality and resources utilization. I can seem a little unfair to other requesters, and if you few new requests keep coming in, it causes saturation to the old and executing ones. Disadvantages: the main disadvantages of using LIFO valuation method is that implementation is incompatible with international financial reporting standards and not accepted under the tax laws of many countries. There is also risk that old inventory items will get damaged or become obsolete. Another is n-step scan. It is also known as n-step look algorithm. In this, a buffer is created for n request or request belonging to a buffer will be serviced in one go. Also, once the buffer is full, no new requests are kept in this buffer or sent to other one. Now, when these n requests are serviced, the time comes for another top and request, and this way all get request to get graduated service. Advantages of n-step scan: it eliminates the saturation of request completely. Disadvantages: requires carefully turning. The zone size in n-step scan must be carefully chosen to achieve optimal performance, which can require additional efforts and expertise. May not be optimal for all systems. The benefits of a n-step scan may not be realized in all systems, particularly those with low disk input-output loads or very large disks. Another one is F-scan. This algorithm uses two sub-queues. During the scan, all requests in the first queue are serviced and new incoming requests are added to second queue. All new requests are kept on halt until the existing requests in the first queue are serviced. Advantages: F-scan along with the n-step scan prevents arm sickness. Some important points about F-scan. Fixed period scan. Disk scheduling algorithm mainly focus on handling high variances in short squeeze time first. F-scan algorithm determines how read and write head of a disk will move in order to handling issue of high variance of SSTF. F-scan addresses above mentioned issue by freezing queue. One can start request that arrive after scan start or proceed in next scan. Thank you.